Hey guys, welcome to my house. It's about 12 at night and I'm in my pajamas, so I'm going to make this quick. We're going to learn about, there's nothing there. I meant to write linear equations. Never mind. We're going to learn about linear equations. Now, I've already taught you the quickest, most efficient way to solve linear equations. Today is not about that. Today is about understanding, because why do we learn math? That's a question that comes up quite often, is why do we learn math? Math isn't about Jill got 5 oranges and gave 2 to Jim, who had some amount of oranges, and then Jill had 11 oranges. No, it's not about these sorts of questions, because when are you going to use that in real life? Math isn't about all these sorts of problems that you do. Math is about a pattern of thinking. Now, the thing about math is all the patterns of thinking in math are connected. They're all the one same pattern of thinking, but we all see it in different perspectives. And I'll prove it to you. In fact, I'm not just going to say it, I'm going to demonstrate it. And there's no better way to demonstrate it than in linear equations. So, I'm going to write something simple and easy on the board. I'm going to write x plus 5 equals 11. And you already know the answer. You already know the quickest and efficient way to solve a linear equation. You probably already got an answer in your head. But today is not about quick and efficient. Today is about understanding. So, we're going to understand a little bit more about the patterns behind linear equations, and then you will see how they're all connected. So, x plus 5 equals 11. The way I'm going to demonstrate how all these patterns are connected is I'm going to show you 2 ways of looking at this. We have x plus 5 equals 11, and since I'm going to show you 2 different ways of thinking, we have x plus 5 equals 11, and I'm going to show you 2 ways of solving this simple problem. The first way of thinking is to think in sequence, like a story. To think, we have x, we get 5, and we have 11. So we have some unknown amount. We don't know what it is. Let's say we have some unknown amount of, well, I said oranges before, let's keep it cliche. We have an unknown amount of apples. We get 5 more, and now we have 11. So it's a story, one step after the other. And in this way of thinking, it just makes logical sense to work backwards and say, we had 11, and we had some unknown amount, we add 5, we get 11. So let's take 5 back away, and we should be able to get back to the original amount. So let's work backwards. Instead of gaining 5, let's take those 5 away. So we have x equals 11 minus 5. And then we just solve it out, and we have x equals 6. So a simple story. We start with unknown amount, we gain 5, we now have 11. So if we want to know the original amount, let's work backwards and take those 5, give those 5 back to the person to find the original amount we started with. So this method should look awfully familiar. It looks pretty much how we've been solving algebra so far, the kind of sequential method. I'm going to show you a different way of thinking, and most of you should be familiar with this. Maybe you've done this you've definitely done this in previous years. And this is called balancing. And it makes sense, and the key is in the equal sign. So we have x plus 5 equals 11, so we're saying the value of x plus 5 is equal or exactly the same as 11. So these 2 amounts are the same, the x plus 5 and the 11. So let's do something interesting. Let's take 5 away from this x plus 5. Let's go x plus 5 minus 5. And obviously, since we took 5 away from here, suddenly it's not quite equal. So the x plus 5, take 5, is not the same as this anymore because we took 5 away from here. To make them equal again, let's take 5 from this side as well. So we take 5 from 11. So now, since we've done the same thing to both sides, they started off equal, we took 5, they're both the same amount again. And so, if we were to kind of solve this out, we say x plus 5 minus 5. Well, what's 5 minus 5? We took those 5 away, so we're just left with x. And we have equals 11 minus 5. And then, obviously, if we solve it out, x equals 6. Now, the reason I'm showing you this is I want to show you how all the different ways, those two different ways of seeing the problem, they seem very, very different, but they're exactly identical. Because while you can see maths through different perspectives and different lenses and use these different methods in analogy, math is actually a single pattern underneath all the different patterns of thinking. So you could think of it as a sequence, you can think of it as a balance, but maths is pure. Maths is an underlying pattern which exists in any way you think of it. Now I just wanted to demonstrate with linear equations just how the pattern of maths is beneath all the different ways you can interpret a problem, and that this way of thinking is exactly the same as this way of thinking. So now you should be able to use balancing equations, and that means you can take or times or divide something from this side, as long as you do it to this side so that they stay the same, and kind of till you break it down into an answer, or you can work sequentially backwards to find your answer. Whatever the problem calls for, you can use any pattern of thinking that you've learned, and it will always remain the same because math is a single connected pattern of thinking. Hopefully that made a little sense. It is a bit late, but math. Thank you. I don't know how to end this video. Shoo, go away.